Now we're going to look at circuit analysis. So that's the next lesson we're looking at. And what I want you to do is I want you to be able to use your knowledge of formulas in terms of resistance, voltage, and current to solve direct current circuits. So when you're solving circuits, there's a couple of rules or strategies that you need for analyzing them. And I got them listed here for you, and you have it in front of you on your sheet. First of all, you need to fill in any known quantities. So anything that's given, you want to make sure is on your diagram. Fill in any quantities that can be solved using Kirchhoff's laws. So Kirchhoff's laws play a very important role when you are looking at a particular circuit. You want to reduce any parallel elements to series equivalent. All right, so that's the key here. Anything that's in parallel, we're going to convert it to series, and what we call it the equivalent, and I'll show you what that means when we do an example. And then you want to redraw the new equivalent circuit, and this might be repeated several times. So I'll put here may have to repeat. May have to repeat. And finally, we're going to use V equals IR to solve any of the missing variables. So there are the 5 guidelines or strategies. So you'll notice that this is not a recipe. I use the word strategies or rules because it's not something that's going to be the exact same every time. Every circuit is different. So let's take a look. So here's my circuit, and I want to solve for all unknowns. So in this case, if you take a look at each resistor, I'm missing a voltage. So that means I want to find my voltage at each circuit. I know my resistance, and I also need to find my current as well. So I need to find the current. Oops. So what do I have to do? I need to fill in all unknowns. Everything's kind of filled in there for me, and that's generally how the circuits go. Now, I am an organized guy. I like to have everything in a chart. So the chart really helps out. You're going to have some people that don't need the chart, and that's fine. But I think the chart is a nice organized way to show you, to figure out all your missing values. So I'm just going to start my chart. V, I, and R will be my headings. I'm going to have, if you look at the subscripts, 1, 2, 3, 4, so I need to have 4 lines. All right, so I have the first one, second, third, and fourth. And I'm going to add a final column on. I'm going to call it total. All right. So if I look at what I know, I fill in the information in the chart because that helps sort out what I need to find. The 6-volt battery, that tells me the total voltage available when you leave the battery. So I know my total voltage is 6. At circuit 1 or at location 1, I know my resistance is 10, and I do not know voltage or current. At stage 2, I know my resistance is 12. I don't know current or voltage. Number 3, same situation. I just know resistance. At stage 4 or resistor 4, I just know resistance. So that being said, I need to follow my rules. So just scrolling back quick here. I've got 1 done. I've got 2 done. So let's reduce this. So what that basically means is I'm going to redraw this circuit, but I'm going to get rid of it, reduce it down to 1 pathway. So how do I do that? First thing I need to do is I need to put that in series. So I'm going to have my 6-volt battery. It's going to come out. It'll go through that resistor. It's going to have 1 pathway here, and it's going to have 1 pathway there. So there's my 10 ohm. This is still my 5 ohm. And this one here, this resistance, I'm going to calculate off to the side. So the resistance at that point now will be, because it was in series before, it's going to be R2 plus R3, which would mean it'll be 12 plus 8, or it's going to be 20 ohms. So this resistor is 20 ohms. So this is drawing number 1. Am I down to 1 pathway? So you'll see over here, it says get it down to a series equivalent. So I only want one pathway. So that means I'm going to have to do another drawing because I'm going to have to combine these two together, the parallel lines together. So, drawing number 2. So again, still have my 6-volt battery. I'm going to go through this 10 ohm resistor. And now that split pathway is going to be reduced down to one path. How do I calculate the resistance here? The 20 ohm and the 5 ohm from above, so up here, are in parallel, which means I have to use my formula for parallel circuits. So it's actually going to be 1 over R equals 1 over, I'll call it R1 plus 1 over R2. So I'm going to have 1/20th plus a fifth. So finding the common denominator, again, you can just use your calculator here. So I'll have a denominator of 20, and it'll be 5/20ths for 1 over R. Please remember, though, you have to flip the fraction. 20 divided by 5 is 4 ohms. So that resistor there is the equivalent of 4 ohms. Okay, so just put this, try to draw this properly here. So this circuit right here, that component, has been reduced down to 4 ohms. So we have got it down to one pathway here. So that would mean that my total resistance around this circuit, if I was to go around this circuit as an electron, I would have 14 ohms of resistance. So that will go in my total resistance for this circuit. That now tells me, or I can now calculate my current, all right, using V equals IR. So I simply have to do my voltage divided by resistance. So 6 divided by 14, and I get 0.43. So there is 0.43 amps of current in this circuit. Now that I know this, anywhere there's a single pathway, I know the current is going to be 0.43. So I go back to the original circuit, and I see that there's only one way to get through the first resistor. So that means all the electrons are going through the first resistor. That's 0.43 amps of current. If I know two pieces of information, I then know the third. So I know V equals IR. So if I have I and R, I now know my voltage has to be 4.3. So that means I have 8 4.3 pretzels passing through that resistor. Okay? So if I had, I'm going to work up here on the red, if I had 6 pretzels to start with, and that's from my battery, and I ate 4.3, that means I am down to 1.7. Okay, so that's how many pretzels I have left, how many volts. So here I am right here at this location, and I have 1.7 pretzels in my hand. I can go this way, or I can go this way. Regardless which way I go, I have to eat 1.7 pretzels. Okay? Going down the first pathway I marked here, there's 2 resistors. So I don't know how much of my 1.7 I have to eat. But if we look at the second pathway, which goes through number 4, there's only 1 resistor there. So I have to eat all 1.7 pretzels. So back to the chart. On pathway going through resistor 4, I have to eat all my pretzels at that point. Okay? What this will tell me is how much current is going down that pathway. Because now I have V and R. I can calculate my I. So V equals IR, so 1.7 divided by 5, I get 0.34. So if 0.34 of the current is going in this direction, and I had 0.43 to start with, then I would have the 0.43 minus the 0.34. And since current is constant here, you can't lose current through a circuit. There's going to be the same amount of current going through each of resistors 2 and 3. And now if I know the current going through there and I know the resistance, I can calculate how much pretzels I have to eat at each stage here. The 12 times 0.09 is 1.08. And the other one, 0.09 times 8, is 0.72. All right, if I was to add these two together, because on 2 and 3, all right, going this direction through those two resistors, I had to eat a total of 1.7. So if you do 1.08 plus 1.72, you end up with 1. It's going to be a little higher, 1.8. So rounding, it throws you off a little bit, but that would give you your total value. And this chart is now filled, so now you have all your information. Okay. So it will be challenging. I got another example, and I'll do that in the next video. And then you're basically looking at a work period on this. So in real time, you can think of it this way. I would do the lesson, it would take a full day, and then you'd have another day to do the homework. So essentially, you're going to be working on this for 1 to 2 days on the homework, and you're going to find you're going to get quicker with it. So let's move on to the next video and the next example.